Hello friends, this is Durga again from IT Varsity, a one-stop shop to learn all the technologies. So as you guys know, this is the backup for the live session, and I might not be able to take any questions through live chat. If you want to practice by seeing these videos, you can go to labs.itvarsity.com and you can choose one of the plans, these ones, and you can start practicing. And if you have any questions, you can actually start writing the questions under discuss.itvarsity.com. That being said, let me start the WebEx session and we will proceed further. So today we'll be starting with the Hive, but before getting into that, let us recap what is covered so far. Okay, so to cover to understand what is covered so far, you can go to this playlist. I will paste this link. So you can use this playlist as reference. So we started with setting up the development environment, and then we understood few basics of Scala as a programming language, and then we covered Spark extensively. Okay. Sorry, not this one. Okay, my bad. Just give me a moment. This is not the one. The playlist is not correct. Let me give the right one. So this is the playlist. We started with Spark. We have covered everything with respect to Spark. Okay. We start with Scala as a programming language. We learned few basics. Then we got into transformations and actions related to Spark. We have covered data frames and Spark SQL. There I only covered how to invoke the SQL from the Spark, but I didn't teach anything related to SQL itself. So we'll see a little bit more details about SQL as part of Hive sessions, which will be starting today. And then we covered streaming using Flume, Kafka, and then performing analytics on top of it using Spark Streaming. So these are the things that are covered. And even if you go to the certification curriculum, we covered everything with respect to HDP-CD Spark certification. And with respect to CCA certification, CCA Spark and Hadoop Developer certification, we have covered the Spark portion of it. Okay. Still, we have Hive and Scoop, which needs to be covered. We are starting with Hive today. Probably 2-3 sessions we'll talk about Hive, and then 2-3 sessions we'll talk about Scoop, and then we'll wrap up. And also, I will share few resources with respect to performance tuning and all those things. You have to go through those videos, and if you have any questions, you can ask me. I will be here only, or we can take care of those things offline also. Okay, so this is the playlist. I'm pasting in the Skype chat, and also I'll be pasting it as part of the live chat in the video also. Okay, so this is the playlist. We'll start from the beginning. Okay, so let us get on to Hive. So when it comes to big data or Hadoop or Spark, it's all about storing heavy volumes of data using distributed file systems and processing using distributed processing framework. Okay, it could be MapReduce, it could be Spark. But if you think about it, at least 70 to 80% of the scenarios are actually related to structured data. Okay, either you can predefine the structure or you can define the structure on the fly. Hardly will try to process unstructured data. Even if you think about Twitter, all the metadata of Twitter is still structured. Only the tweet, when it comes to analyzing the tweet, then you have to deal it deal it as the unstructured data. Otherwise, to perform analysis on the metadata is well structured. It's if you know the structure of it, or if you use the Twitter APIs, you will get in the form of JSON, where you will get the all the details. Okay. Similar is the case with videos. Even with respect to videos, unless you want to process video itself, rest of the metadata with respect to video is also structured. The properties and all of them will have structure, and hence, when it comes to processing the structured data, as SQL is there in the industry for quite some time, if we have SQL type of interface, it will be faster to develop. Okay, faster to develop, faster to analyze. Most of the data analysts, business analysts, are well versed with SQL. So if we provide them data and if we provide them structure on top of that data, they can leverage their knowledge of SQL and they can perform certain level of analysis up to certain extent. Okay, so writing ability to write SQLs on top of structured data is very key, is very important. And Hive is the technology which will serve that purpose. Okay, so without wasting the time, first let us understand the architecture of Hive and how we can access Hive. And there are multiple ways to access Hive. And then we'll get into DDL, DML, and SQL. Okay, if you go to Ambari, and if you click on Hive, you will understand the architecture of the Hive. You have 3 servers. One is Hive Metastore, second one is Hive Server 2, and third one is WebHCat server. Okay, and then clients are installed on all the nodes. And to store the data or process the data, there are no components with respect to Hive. Hive works on top of some other processing engine and some other file system to process as well as to store the data. The file system can be HDFS, the file system can be S3, the file system can be Azure Blob to store the data. And for processing, you can either run in MapReduce context, TES context, or Spark context. Whatever processing engine you want to use, you can integrate your Hive into that, and you can use that. So Hive is primarily to define structure on top of data and use SQL type of interface to communicate while processing the data. How you want to process the data, it depends upon the underlying framework you want to use. It could be Spark based, it could be MapReduce based, it could be TES based on Hortonworks clusters. Similarly, to store the data, Hive provides certain interfaces, but how it stores internally depends upon the underlying file system. It could be HDFS, it could be S3, it could be Azure Blob Storage. Okay. No, local file system, it will not. It might work, but you don't use local file system. Okay, so what are these then what are these components? Because to store the data, we are telling that it will use HDFS or S3 or blob storage. To process, it will take MapReduce or some other distributed processing framework to process the data. Then why these 3? We'll come back to that in a moment. So Hive Server 2 is primarily to connect to Hive and issue the queries. And I will talk about Hive Metastore in a moment. Okay, but when it comes to storing the data, it uses some distributed file system. In this case, it's HDFS. When it comes to processing the data, it can use TES or MapReduce or Spark. Okay, it's up to you. You can actually control which engine you want to use. That's why, with respect to processing and storage, there are no components here. Now let us understand what is the purpose of Metastore. For that, before doing that, let me log into the cluster. So Hive also have command line interface or REPL. Okay, so if you type Hive and hit enter, it will launch the Hive command line interface, which can understand Hive commands. It's similar to SQL Plus if you are familiar with respect to Oracle or MySQL command line interface. Almost all the databases have that. Even Scala have it. Java also they are trying to introduce in 1.9. Okay, so here, once you are in Hive, if you want to list the databases, you can run show databases command. There are hundreds of them because there are many users who are using this. There are 861 databases. And to create the database, you can run create database command. Okay. If not exists is to gracefully handle the situation of database already exists error. If you use if not exists, if the database does not exist, it will create. If it already exists, it will just ignore. So as I already have the database, I'm just using if not exists, and I will recommend you guys to create a database with your database name, with your OS username. Okay, it will create the database, and you can use command called use to switch to that database. Okay, to display your database name, there is something called 1 minute. Hive CLI print current DB. Hive CLI print current DB. So if you want to override any parameter, you can use this set command. By default, this is false. Okay, you can set it to true. If you set it to true, it will show the database here. Okay, I can also actually, let me do this real quick. I'm signing out and logging in as admin. And I will change it on the service itself. Okay, let me custom Hive site, add property. For everyone, when you log in, you will get the database automatically. So I have to restart the service. Okay. So once it is restarted, whenever you log in, you will see the database directly here. And then we can say show tables command. Show tables will list the tables. I think it is being restarted, that's why. Okay. There are a bunch of tables in this. And if you recollect, I have all the data in this location, public retail underscore DB. For my retail database, I have one shared location called public retail DB. And DFS is variation to Hadoop FS. It's alias to Hadoop FS. So if you want to run any Hadoop FS commands from Hive CLI, you have to use this command called DFS. So with Hadoop, on Linux command prompt, we say Hadoop space FS space -ls. Instead of Hadoop space FS, we can use DFS. Okay, and it will list the subdirectories in that location. And if you go to one of these directories, let's say departments, and then do cat on this. The data is comma separated. There are 6 records. It's a well-structured data. There are only 2 fields within dataset. And if you know the column names and all, we can define a structure, and then we can query. Okay. Now let me define a structure. I am dropping this existing table already, which is departments. Okay, and then I'm creating table, something called external table in this case, with the name departments. Okay, it has two fields, department ID, and if you want to get the data model, you can go to the MySQL database from which we pick this data. Okay, department ID is of type integer, so here I'm defining as int, and then department name have alphanumeric characters, so you can define it as string. I will explain the data types a little bit later. So already there is data, and we are trying to define structure on top of it. Okay. Here the data is comma separated. So I am saying row format delimited fields terminated by. So what I'm saying is each row the format is delimited fields terminated by a character. What is that character? It is comma. Okay. And then the data is text data. And as it is text data, we have to use stored clause and text file because we are trying to store it in text format. And then hit enter. Don't worry too much about the syntax. I will explain a little about all these things a little bit later. So what is this? We have given the table name, we have given the column names, we have given the data types, and we have mentioned the okay, I have to specify the location. So this is not correct. Drop table departments. Okay. Stored as text file, and then location /public /retail underscore db department. So on the existing table, I am creating external table on the existing data set. Okay, there is a permission related issue. So let me create a managed table here rather than external table. Okay, then I will load the data. With the managed table, you don't need to specify the location. I will explain what will happen in a moment. I'm just creating this table. Okay, and then I'm loading data, load data, local in path. So I'm copying from the local file system. My local file system for this data is data /retail underscore db /departments. From this, I want to copy the data into table departments and hit enter. Now the data is copied. So if I run this command, describe formatted departments, okay, it will give all the details about the table departments. This is called as metadata. The information about your table is called as metadata. It has column names and data types. Location. So this is the HDFS location. As I have mentioned to you earlier, your data will be there in HDFS. Okay. And then this is all related to the file format, and then this is the field delimiter. Okay, so this is called as metadata. So you need to store this information somewhere, right? If you try to store it in HDFS, HDFS is primarily intended for larger files, not for the smaller files. This metadata is only few bytes to few kilobytes. It will not be very big. And also, if you store in HDFS, the access is relatively slow, especially when you try to read the lesser data. It's not that fast, and also it is not very reliable. Okay, for all these limitations, instead of storing this metadata in HDFS, they have decided to put in the relational database. Okay, and when you have the relational database, there has to be a server which will be connecting to the database and interact with it whenever we issue certain commands. For example, when we create table, it has to populate certain metadata in the database. When we issue the queries to compile the query into the underlying native language, it has to read the metadata again from the relational database, right? So for that purpose, there needs to have some web server between your Hive and Metastore, and that web server is Hive Metastore. Okay. So if you go to Hive and click on summary, you see Hive Metastore. This is nothing but a web service which will act between Hive binaries and the database which will store the metadata. And where it is, so if you go to the configs and if you go to advanced, you will see the Hive Metastore details here. Hive Metastore is running on nn01.itversity.com. Database username is Hive, database name is Metastore, and the password is encrypted here. Okay, so this database actually have certain tables which will store all the information relevant to the structures on the tables. Okay, so now let me show that I am connecting to another session on gw01.itwatch.com, and from here I will go on to the nn01, and then I am logging in as MySQL -u root -p. Okay, and then show databases, and it is not showing Metastore database. Okay, database is on the gw01.itwatch.com. Sorry. Metastore is running on nn01, but database is on gw01.itwatch.com. So here, MySQL -u root -p. Okay, and then show databases. There is a Metastore database here. Use Metastore. This is MySQL, and show tables. And these are the tables which will store the metadata. Okay, so these tables will be touched whenever you create table, you alter table. Some of the rows will be updated here. When you issue a query like this, so the query will look like SQL. In the traditional RDBMS, what will happen? This SQL will be compiled into native the underlying technology's proprietary language. For example, if it is Oracle, there is something called SQL engine, and that SQL engine will actually compile this query, which is understood by the SQL engine, and then it will do the IO and all those things to process the data. In this case, when we run this query, there is a bunch of binaries related to Hive. Okay, what is Hive? If I come out of this and go to this location, you also have the access to this location, read-only access. If you go here and go to lib, there are a bunch of jar files. Okay, so this is what Hive engine is. Hive engine is nothing but a bunch of compiled Java programs. What it will do, it will actually interpret SQL queries like this, or creatable commands which we have executed earlier, and compile into few Java programs. If it is a creatable command, it's a simple Java program which will update your Metastore tables and return success message or failure message. If it is query, it will compile into MapReduce program. Okay, and that program will be submitted as jar file, to execute as a MapReduce job. And hit enter. Now you will see that it is actually starting the MapReduce job. So under the hood, what it is doing, it will compile that into a Java program which uses the MapReduce API, and that jar and it will be compiled into the jar file, and that jar file will be submitted into submitted as MapReduce program on the cluster, and then you will get the
only on NN0 as per the number. You have seen the number NN01 we have different. So this
no, that is Hive Metastore. That is different. Hive Metastore is a web server. So when I run this command, select count of 1 from departments, I am running it from the gateway node. Okay, gateway node and all the other nodes in the cluster already have the Hive binaries, and it have XML files also, configuration files, which will make sure that Hive understands the cluster composition. On top of it, we also have started a Hive Metastore server. Hive Metastore is just a web server which will be used to interact with the Hive Metastore database. Wherever it requires access to the Hive Metastore database, it will go to the Hive Metastore web server. Okay, so when you run this query, where it is required to touch Hive Metastore to get the metadata for this table. Okay, and use that metadata to compile into MapReduce program. To get that metadata, the metadata is there in these tables. Okay, if you understand the web application architecture, whenever you have to connect to the database, you have to go to the JDBC and all those things. Okay, so this Metastore is nothing but a web server which will be used whenever it requires access to the underlying database to get the metadata. It will not go through Hive Metastore. Okay.
That web server will be running on NN01.
Yeah, that web server is configured on NN01 in this case. It can be configured anywhere, but your cluster should
not on gateway node.
Gateway node. If you want, you can configure theoretically, but it is not a good practice. Gateway nodes are primarily to submit the queries. Okay, I should not even configure the SQL database on gateway node. Okay, so here with the same name, there are two things. One is Hive Metastore server, and the other one is database with the name Metastore. Don't get confused between the two. One is database, and the other one is the web server. Okay, you can, as long as there is connectivity between those things, you can configure these things anywhere. Anyway, so in this case, when we run the create table command, to preserve this metadata, it has to connect to the Metastore database and update few tables in that. And also when we run the query, it has to retrieve the metadata of the table, compile it to make sure it's a valid table name, get the metadata, and create the jar file, which will be submitted as a MapReduce job. In both the cases, the Metastore will come into picture, the Metastore web server will come into picture. So that is the purpose of this Hive Metastore server. Okay, and then Hive server 2, if you want to write JDBC based programs, or if you want to connect the third-party tools to the data which is stored in HDFS, and there are Hive tables on top of it, and generate reports out of it. For example, Tableau. Tableau is one of the BI tool. You want to connect Tableau with your Hadoop cluster through Hive layer, because Hive is nothing but bunch of tables. Hive tables are nothing but typical tables. If you can issue queries in the form of SQL against those tables, you can generate reports out of it. What Tableau will do, it will provide you a layer where you will drag and drop your dimensions, facts, measures, etc. And based upon what you have done on the web interface or client-based tool, internally it will generate a SQL and then fetch the data and run report and visualize the report for you, right? So for those kind of tools to get visualization tasks done, you need to have a server. that's what that's where Hive Server 2 comes into picture. You can use Hive Server 2 to develop any JDBC programs, or use third-party BI tools to connect to Hive tables using Hive Server, and then you can generate reports out of it. That is the purpose of Hive Server 2. And then Web HCAT. There are 3 components which are running. Web HCAT. HCAT stands for H catalog. Okay. Sometimes when you do some programming, you need to understand the metadata. Okay. So one way to get the details about metadata is run your describe commands here. Describe formatted departments, or go to the underlying Hive metastore tables, reverse engineer this data model, and then start querying from there. Both are not practical. If you want to develop a program using JDBC, issuing the describe command is not very straightforward, and also reverse engineering this data model is also not possible. For that purpose, they have provided APIs, and Web HCAT server is the server which will serve those APIs. I think it is REST-based APIs. So if you want to get metadata of any table and embed as part of your application, you can make the calls through Web HCAT server, and it will give you the metadata, and you can develop on top of it. Okay, so that is the purpose of Web HCAT server. And Hive client should be installed wherever you want to run the jobs. What is Hive client? Hive client is nothing but bunch of the jar files and appropriate configurations. Without configurations, Hive does not know where your cluster is. Okay, that's why in this case I have configured Hive on all the nodes, but typically we will configure Hive only on the gateway node. Okay, so that is about Hive architecture. Now launching Hive, we have already seen one approach, which is just typing Hive and hit enter. It will launch the Hive for you. Okay, see, now the database came up automatically because I have set it to true on the cluster level. Okay, this is one way of launching Hive, and then I will come back to other ways of launching Hive in a moment. You might want to see the values to the parameters. If you just type set semicolon and hit enter, it will give all the parameter names and values for this session. Okay, so if you see, some of them are prefixed with system, some of them are prefixed with env, and some of them are prefixed with Hive. Some of them are prefixed with DFS, so on and so forth. So set will give all the parameters, names and values. If you just want to get any one parameter, for example, DFS.block size. Okay, if you just want to get the value of it, you just have to run set and then the parameter name. If you know the parameter name, you just give the parameter name, and it will give the value. Okay, if you want to set it to a different value, you just have to say like this and give the value. Okay, so set is very, very powerful command to override any default settings at runtime. Okay, now if I exit, you can access the configurations by choosing Hive as a service and go to configs. You will see all the configurations available here. Okay, but you will not be able to update or modify because you only have read-only permissions on this. From where we are getting these things on the server, there is a location called /etc, which is standard configuration location for any software deployed on Linux. And then there is a subdirectory called Hive, and then there is a subdirectory called conf. If you go there and run ls-ltr, there are a bunch of XML files, .sh files, properties files. Okay, all these things along with the defaults are the ones which we got using set command. Okay, some of the parameters might not be available even in this. It will inherit the defaults. Okay, and then at runtime, if you want to overwrite, you have to use the set command. And then you might want to run a particular command and come out of it instead of, so when I type Hive and hit enter, it is launching Hive command line interface and it is waiting for you to issue commands. Sometimes we just want to run the commands and come out of it. And the advantage of that is you can integrate as part of your shell scripts. Okay, so if you want to integrate a particular, or if you want to invoke a particular command using shell script, typically in SQL Plus, what you will do, you will, I forgot the complete syntax, you will use some concept called EOF concept and give the script, pass the contents of the script to this EOS, and then it will execute that script. Instead of struggling with all those things, Hive have a command called hive-e. Okay, so here let us say I want to get the count of records in departments table which is under dgadraju database. I can say hive-e use dgadraju select count of 1 from departments and hit enter. Now you see it has run the query and came out of it. The advantage of this is I can say vi run hive.sh and then copy this command. Let's say you have a very complex shell script. Now you can come out of that file and then chmod +x run hive.sh and then I can say run hive.sh. Okay, so that is the advantage of hive-e. If you use Hive, it will launch the command prompt and it is not possible. Okay.
All this can be done in local system, or you need to set up a separate server for these?
You cannot do a lot of stuff in local file system. If you want, you can do. You have to download the Hive binaries, untar it, and then it will come with a in-memory database, Derby database. Okay, and you can use that, and you can try all these things using local file system also. Okay, or you will have to use some environment where you have the cluster and then Hive database on top of it. Okay, the default is Derby, which is in-memory database. Anyway, so this is the advantage of using Hive-e. You can easily automate your shell scripts if you want to do certain things as part of the application. Because Hive is nothing but SQL. You cannot develop a standalone application using SQL. You have to use some other programming language and develop application, either schedule it if it is batch processing or deploy it on a web server or application server to run it perpetually, right? So now if you see, this actually generated a lot of logs and we don't want to capture this thing. We want to discard all the unnecessary information from this command. Okay, so even though everything is displayed here, some of the information is standard out and some of the information is standard error. Okay, so standard, if you are familiar with codes for standard in, out, and error, 0 is standard in, 1 is standard out, and 2 is standard error. So here I want to redirect all the standard error into a log file. Okay, so two, if you give only one greater than symbol, it will always overwrite the existing file. If you give two greater than, it will append to the file. For the first time it will create, from the next time it will append. Okay, so let us give query dot log and then one results and hit enter. So if you see, you are not getting the logs generated now because they are being redirected. And these things are important. Hive is nothing but SQL. You should know how to use it and develop applications around it. Okay, now you can see ls-ltr, there is query.log, and you can see the query.log. Except for the result, everything else came here. And for the result, you can say cat results. And you can see 6 here. Okay, so this is how you can integrate Hive-E along with your scripts. And there is another option called Hive-F. So if you have very tens of commands which you want to run, then you can put all the valid Hive commands into one script and give some extension like .sql or .hql, and then you can run Hive-F and give the script name, and it will execute. Okay, but
any format for the script?
no, there is nothing. No, nothing. No format. You can give any name, any extension. Only thing is you have to pass it using Hive-S. But one disadvantage with Hive-F is even if one script fails, one command fails in middle, it will abruptly stop it. There is no way to gracefully handle that and move on. That's why I don't emphasize a lot on that. I use shell scripting on top of Hive commands, and I will execute Hive commands using Hive-E. And with Hive-E, you can give as many commands as you want with semicolons operated. Except when I want to dynamically generate something in between and then issue the Hive-E command again, I will give series of commands using one Hive-E. Okay, and then sometimes we want to go to the logs of all the executed commands, and you should know the location of where the logs will be stored. One way is by redirecting the standard error to some other thing. You can get some information. Sometimes you just want to go to the past and get the errors. So for that, you can go to etc hive conf and then go to log4j.properties. Most of these technologies use log4j. Okay, Hive log4j. Okay, and here, so the log directory is this one, java.io.temp_dir /username. Okay, so what is java.io.temp_dir? Whatever is the temp location on that underlying server. So on Linux server, /tmp is the temp location. And then /username. So what is the username? This one, T Gadraju. So if it is yours, you have to give your username. And then if you go to that location and then ls-ltr, it is actually pushing logs to this location. Every day it will rotate, and you will see a new log file, and you can get logs from here. Okay, so as part of developing the applications, instead of going to this hive.log, you might want to override at runtime. Okay, How to do that? Again, using the set command. Okay, now if you go to /etc cd cat etc hive conf hive log4j.properties, and then most. So hive log dir is the parameter which you need to override to write into a different location. Okay. So now what I can do is vi run hive.sh. I can say conf hive.log.dir equal to /user dgadraju. I think this is the valid command. Let me see. Okay, it is not the valid command. --hive conf. --hive conf hive log file equal to dg. Okay, there is some issue. Okay. User. Okay, this is not the correct location. Okay, I got it. It's not user, it's home. Okay, now it will work. So at times what will happen is when you are writing a complex application which is issuing bunch of high queries, you might want to write the log into a separate file for each and every query. Okay, in that case, you can override those parameters like hive log directory and hive log file, and you can store it into whatever log file you want. And here you can see there's a directory called dg. So there's a file called dg, which I have given as part of hive log file. And if you look into that, it have actually generated all the log files. And all these things has to be automatically taken care. So I have written a application which uses Scoop and Hive, both the technologies. I use shell scripting on top of these two things as a wrapper. There is a properties file where which will have the table names and a few other important information to generate the where conditions and all those things automatically. And then for each query, I want to write into a different log file using some unique identifier. And then after each query, I want to pass through those logs. And if there are any errors, I want to send email to operations using sendmail, Linux-based sendmail application. So to do all these things, if I write everything to one common log file, passing through that log file will be a nightmare. Yeah, rather ideal way is you should not even go back and pass. While it is running, while the logs are being generated and redirected to some temporary file, it should identify any errors or exceptions, and those things should be notified. That is how you should be writing the application. And for that, you need to have a programming language. You cannot do Hive and Scoop and try to develop application. You need to have a programming language or a scripting language around those things. And that is more important than learning Hive. You should know how to integrate these things and build applications Okay, then only it will be manageable over a period of time. Okay, so this is how, these are all very, very important information, and you should know how to leverage these things while building applications. Okay, now coming back to properties. Okay, so typically you will not use OS user databases with databases and OS users with your personal usernames. There will be functional users for each module or for each application. There will be a user, and we'll be using that username to submit all the applications, all the Hive queries, whatever it is, right? And for that user, you might want to override some parameters for all the jobs that are being running by the functional OS user created with the name of functional, with some functional name. Okay, so if you want to override bunch of parameters, every time setting up those things as part of your program might not be very practical. For that reason, you might be familiar with .bashrc or .rc. If you are Linux users, you will be familiar with these things. What is this .rc or .bashrc? These are hidden files for setting up the environment variables. Okay, so if I do ls-altr in my location and then grep bash, you can see .bash underscore profile and .bashrc. And if you say cat bashrc, there is some script which is actually running some other global bashrc. And if you want to override or if you want to give aliases to some of the Linux commands, or if you want to export few important environment variables to run your applications, we typically use this .bashrc. Okay. Similar to that, whenever Hive is launched, if you want to override certain defaults, you can create something called .hiverc. Okay, and in that you can override the parameters. So let me show you an example here. Here I am saying hive-e and set Hive execution engine. This will give us what is the current value for this Hive execution engine for this parameter. The current value is MR, which is MapReduce. So because Hive execution is MR, whenever we issue any select queries, typically it runs in MR. There is another interface called TES. Okay, TES is Hortonworks promoted proprietary execution engine, which is similar to MapReduce, but it instead of running in the MapReduce framework, it directly runs under Yarn framework. Okay, nowadays TES is not so much relevant, so don't worry too much about TES. As long as you know how to write SQL in Hive, you know TES, you know Impala, you know Spark SQL. Okay, so don't worry too much about these things. This only thing is the way it executes will be different, whether it is TES or Impala or MapReduce or Spark SQL. The way they execute are different, but the syntax to write the queries will be same. Almost same. Anyway, so here let's say I want to change it to TES. So what I can do, I want to change to all the Hive commands which I will be running using this user. So here I can say set Hive execution engine equal to TES, and we can have as many parameters as we want, and then come out of it. And also we can actually say even the log files. Set Hive log dir equal to, let's say I want to write into my location. Home. Earlier I have shown with --hiveconf. Either you can use that, or you can also use it like this. And then if I launch Hive now, Okay. I think Hive log directory is some special means it's from log4j.properties. I think we cannot use it in the .hive.rc. We have to pass using hiveconf only. Okay. Now let me launch this. Now it will work. And now if I say Hive execution engine, it is test because in .hive.rc I have modified. And then I can say this one and then select count of 1 from departments. And now the interface which runs the test will be a little bit different. See here, with MapReduce you have seen different type of feedback, and here you are seeing different type of feedback. Okay, so this is the relevance of .hive.rc. And .hive.rc is very frequently used while integrating the third-party UDF. We have to add jar file and we have to create something called temporary function. In case if you want to use third-party user-defined functions, even in that case, we will use .hive.rc quite extensively. It is very important to know the relevance of .hive.rc. Okay, and on top of this, so far what we have covered the architecture of a Hive. We have understood the relevance of Hive Metastore, Hive server, and then we have just created a simple table, and also we have seen how many types we can launch Hive, and how we should integrate with the shell scripting, etc. And finally, we have seen the relevance of .hive.rc after looking into the using custom locations for the logging purposes. On top of it, you can also use Ambari. Okay, once you log in to Ambari, if you go to this tiles icon, you have Hive view. You can choose this Hive view. Okay, Hive server is failing. Okay, then probably there is something wrong. Okay, now let me try again. Okay, even if this ATS test fails, that is fine. You can click on this query. Okay, you can choose the database. In this case, let me select D Gadraju, and then we can actually create table. We can select data from the table. You can do whatever you want. In this case, I am selecting from departments and execute. And you can see the results here. Okay, it is still running.
The Spark 2 coming in. What is the relevance of Hive? Because Spark itself has this rendering functions.
See, Hive, in case of Hive, there are multiple components. One is Metastore to store the metadata. Second one is HiveQL. Okay. Why the results are not coming? Yeah, we got the results. Okay. So when it comes to HiveQL, the syntax is same for irrespective of the execution engine you are using. And to get the metadata, if you are running in Hive context, it has to connect to Hive Metastore. Okay, so for you instead of viewing from Hive, you should view it from SQL perspective. As long as you know SQL, you can run it in Hive if you want. You can run it in Spark. It shouldn't be any difference.
Now, what is I mean, like Spark 2 also got that inline functions, right? That was the difference earlier between Spark SQL and
No. See, Spark, even earlier also, if you
have to export that Hive context and implement that.
See, there are two things. One, you are mixing up the things here. One is running in Hive context is different. Running Spark native is different. Spark native you will use when you don't have predefined structure. Okay, if you already have a predefined structure, then you have to use Hive. You can use Hive. Okay, there is no
Then in
need
that
to.
cases, you can use it. Spark SQL is used when there is
I didn't
there is
understand.
no, like, you are telling if there is structure for that, you have to use.
If you already have a Hive table, you can use Spark in Hive context. Otherwise, if you use Spark SQL context, Spark native SQL context, you have to create case class, you have to write map functions, you have to assign it to the case class, you have to convert it into DF data frame, you have to register it as temp table, then only you will be able to query. If you have 10 tables to join, you have to do it for 10 different tables, right? If you already have a predefined table using Hive, why do you have to do all those things? All that overhead will be gone.
Generally, Hive runs in MapReduce so, and Spark Reduce.
No. If you
Execution engine.
No.
So,
No.
better
Again,
performance will be achieved.
no. You are mixing up the things. Even with Spark, if you run using Hive context, still it uses Spark execution framework only. It will not use MapReduce execution framework. Okay, that's what I mentioned earlier also. If you have Hive, you have SQL query. Okay, if you run it in, if the execution engine is MR, it will convert into MapReduce job and submit as MapReduce job. If you use test, it will submit as an AM job. There is no MapReduce in that. If you use Hive execution engine as Spark SQL, okay, it will execute in the Spark mode. It uses completely different framework. But the common point here is Hive metastore. To get the metadata, whether you are running in Spark execution engine or test execution engine or MapReduce engine, it has to go to the metastore server to fetch that metadata and do the validations, generate the code and all those things.
Only thing is we'll be easily able to create tables and all in Hive, whereas in Spark SQL it is bit we have to create the class. Then register as temp table. So we can achieve what I meant to say is we can achieve whatever is done in Hive through Spark SQL. Using native SQL context of Spark.
Yes, you can use using native SQL context, but
it's time consuming.
Yeah, you have to see if you already have predefined tables, use Hive context directly. There is no need to pass the data and then write SQL on top of it. If you don't have Hive predefined table, then there is no other option. You have to use Spark SQL native context only using data frames concept. Okay. Anyway, so now let us get to the syntax and semantics of Hive. Similar to, so one of the common feature between traditional RDBMS and Hive is the syntax will be similar. To create tables, you use create table command. To load data, there is a load command similar to bulk load. There is insert command, and then to query, you use select queries. Okay, but one of the major difference between traditional RDBMS and Hive is in traditional RDBMS, your underlying database, your underlying data and the processing engine are tightly coupled. For example, if you create a table in Oracle database, and if you insert the data, you don't need to worry about how the data is stored inside the database. It uses its own proprietary delimiter between the fields and all. Whereas in Hive, the file, the way data is stored, and the structure that is defined on top of it are completely decoupled. They are not tightly coupled like in SQL engine. For that reason, while creating the tables, we might have to tell what is the structure of the data while creating the table, or what could be the structure of the data which will be loaded in future. Only then we will be able to create the table and make it working. And on top of it, second major difference, when it comes to traditional RDBMSs, they are called as schema on write. What is schema on write? Schema on write is when you create the table, right? In traditional RDBMS, you say create table, table name, you give field names, you give data types of each field, you give precision, okay? And then you create check constraints, you create not null constraints, you create primary key, foreign key, all these kinds of constraints, right? And then when you try to insert the data, even though from the top of the surface, you see insert into table, table name, values, you give the values. But to execute that insert command, whatever rules you have defined, those rules have to be validated against the data that is being inserted. For example, take the example of departments table. It has two fields, department ID and department name. Department ID is of type integer, and department name, let's say we have given only 5 characters in traditional RDBMS. If you try to insert a department name with 6 characters, it will fail. That means that insert command is actually doing certain validations against the metadata that is used to create the table, right? That is because it actually check your schema while data is being loaded. It is called as schema on write. Okay, so all the traditional RDBMSs are schema on write. What type of checks it will do? The checks are integrity constraints, data types, precision, all these things. Okay, so for mission critical applications, transaction based applications, it is very important to perform these checks at the data being loaded. Otherwise, if you have to develop everything from scratch, your development cycle will be very big. Okay, think about it. If you want to check, if you want to perform all the checks for each and every transaction that is going on across all the tables through your application layer, your application logic will become much wider compared to leaving it to database, right? It works very well for transaction-based systems, but at the same time, when you try to load huge amounts of data into those tables, because for each and every row it has to perform all those checks, the overhead can be counterproductive. It takes a lot of time to load huge amounts of data. Not only Hadoop, even if you think about Redshift, which is AWS product, MPP, massively parallel processing database, or Greenplum, Vertica, all these things, they don't perform checks while loading the data. That's why they can load data much faster compared to RDBMS. And one of the common practice, even with respect to Oracle, is if you want to do bulk load, disable the constraints, load the data, and enable the constraint with no validate. Again, if you validate, if you try to enable with validate, it will take forever to validate. Rather than that, what they will do, if they are confident about the data, they will just disable the constraint, load the data, and enable it with no validate. So whatever data is there, it will not validate, and the load will be much faster. Okay, so Hive is similar to the MPP platforms, wherein it will not do any checks, garbage in, garbage out. If you define a table with some structure, and if you try to load data which is completely inconsistent, completely not inconsistent with the structure defined, data will be copied without any issues. But when you try to read, you will see all kind of weird effects because of that. So it is called as schema on read. Traditional RDBMSs are schema on write. Hive is schema on read. Okay, and now let us start creating the tables. Okay, so we have, so you folks are seeing return_db, and we have written quite a lot of programs using Spark earlier. Okay, now let us understand the metadata of the existing tables and try to create tables for Hive. Okay, so in this case, you can log into MySQL database where we have where we can consider it as a source database. MySQL -u retail underscore DBA -h and then 01.itversity.com -p. Password is itversity, and then use retail underscore DB. So this retail underscore DB have access to 3 databases: retail underscore DB, retail underscore import, and retail underscore export. So if you want to create your own tables on MySQL for whatever reason, use the other 2 databases, retail underscore import and retail underscore export. Don't touch retail underscore DB. You will not have permissions to create tables or to insert data into those tables. Anyway, if I say show tables, there are 6 tables: categories, customers, departments, order items, orders, products. Okay. So we can run this command called describe categories. And let us say we want to create tables for all these 6 tables and hit enter. So there are 3 columns: category ID, category department ID, category name. Category ID and category department ID are of type integer, and category name is varchar of 45. Okay. So now let us understand how to create table for this in Hive. Okay, so I'm launching another session. Okay. So I'm creating a new database. Create database wavelabs DG. Okay. So now let us go to the Hive user guide to get the syntax. Hive user guide. In this case, you can click on Apache Hive. So this is the main documentation, and in this we are talking about DDL. So you can click on this DDL, and if you scroll down here, so if you understand this, then you are familiar with the entire DDL of Hive, only this portion. Okay, there is nothing beyond this. If you need some help at the time of certification, go here and try to get information as quickly as possible from this. Okay, and here while creating the table, you can either create managed table or external table or temporary table. If you want to handle the situation, if the table does not exist, you can use if not exists, and then you can either prefix your database name or switch it to the database name the way I have done, and then give the table name directly. Okay, and then you can define the column names with the data types. There are some constraint specifications also, but very limited, not like traditional database. And also some of the things. So if you go to the data type, these are different data types which is support, which include varchar, and these are only added recently from 0.12. Before that, there is no char, varchar, date, etc. in the earlier versions of Hive. Okay, and most of these data types are informatory, which means that even though you specify char or varchar, internally it will store it as string only. Just to limit the changes you need to make, they have provided support for this. For example, if you know how to query metadata I'm not sure whether there is show create table. Yeah. So if you see here, I have run a command called show create table categories on MySQL. Okay, so we can copy this one to Sublime Text or something. So I think auto increment is not supported. All these things can be deleted. Okay. And then copy this one. Yeah. Copy this one and go to Hive and paste it. Okay. I think that these are back quotes. It is complaining. Okay, after int we cannot actually. The issue is not. So with int we cannot give the size. Varchar we can give. So they mixed up the thing. Earlier there was no varchar. We have to change it to string. So people might have complained that okay, we have hundreds of tables which we might want to create in Hive, and we have to change all these varchars to strings, and then probably they might have uh, added support to varchar. And these things are only informatory. Okay, internally it will be stored as string only. Okay, ideally you can easily develop a simple metadata mapping table, store the metadata into the table, and then apply the rules saying that if it is varchar or char or some other alphanumeric type, change it to string. And that's how I have done. They unnecessarily added all these things. Anyway, so these are all the types which you can give while creating the tables. It has tiny int, small int, etc. Big int, boolean, float, double with precision, string, binary, timestamp, decimal, blah blah blah. And then there are other types also. These are all primitive types, and then there is array type, map type, structure type, union type. So array type is so it's kind of, if you are familiar with SQL plus PL SQL, you have varying arrays, you have nested tables, and all those things. So these are similar to that. Array type is similar to varying array. You can actually give a column of type array, and you can actually have as many values as you want. Okay, anyway, we will come back to this in a moment. And then you can give a comment at the table level. If you want to partition by, you have to use partition by clause. We will see what is partitioned and clustered by in a little bit later. And then skewed by is also similar to that. And the other important clause is row format clause. Okay, so when I create the table here, I did not specify the row format clause. Okay, so to understand the default data type, what you can do, you can create table like this, and you can insert into categories values 1 testing. I think I have to put in single quotes. Okay, now I am creating another one. I can say select star from categories. And if I want to see how the data look like, here I'm coming out of this MySQL and then running Hadoop ss-get apps Hive warehouse. I will explain the relevance of this location in a moment. And then wlabs dg.db categories. I'm copying the data from HDFS location to the local file system. And then I'm going into that directory categories. And if I do ls-ltr, we can see a couple of files. And if we open this one, you see here, Control A is the default delimiter. It's a special character. I think it's a /u001 or something. Okay. So this is the default delimiter. If you do not specify while creating the table, it will use this one as the delimiter. If you want to specify the delimiter, row format fields terminated by. So to get the row format clause, you can scroll down here. Row format delimited fields terminated by whatever character you want to use as delimiter. Collection items terminated by. Collection items are array. So if you want to specify a separate delimiter for array, you can define that. Map keys, if it is map, this will be the delimiter. By default, line terminator is new line character. If you want to use some other character, you have to specify lines terminated by and give the delimiter. And then this will tell how the null should be defined. Okay, because unlike traditional RDBMS, it's not proprietary here. We have to tell how the null has to be represented. By default, I think NULL is considered to be null, but in many cases you have to define what is our null character. Okay, and then file format, default is text file. If you want to use something else, you have to either use sequence file, RC file, ORC, Parquet, Arrow, input format, and you can give custom format all like this. Okay. So now in our actual data is comma separated, and when we create the table, data is using Control A character. So our data is out of if I try to load already comma separated data into this table, and if we try to query the data from this table, then we will see incorrect results. Let me do it here. So I'm loading data from this location. I will explain load data command a little bit later. I'm giving local path here, data retail_db categories into table categories. So all the files in that location will be loaded into this table. Okay. Now let us first see what we have in this location. So I'm going to other window and saying cat data retail_db categories, and you can see our data is comma separated. Okay. Now we loaded the data into this table categories. Now if I run this command, select star from categories, what do you think will be the result? Our data is comma separated. The data which we try to copy into this is comma separated. But as while creating the table, we told that Control A is our delimiter, and we loaded the data. It didn't fail while loading the data. Happily, it copied the data. Now, can you guys guess what will be the outcome of this command? Will it error out, or will it show incorrect results? Or if it is incorrect results, what will be our guess? How the data will be displayed? Any guesses? So let us run this. It showed null except for these two, which we have inserted earlier. Okay, now let me do one more thing. I am dropping this table. Okay, I am actually saying this one as varchar of 45. Everything as varchar of 45 or string. We can also give it a string. And now I am recreating this table. And I am loading the data. I'm not inserting any data, I'm just loading the data. Again, data is loaded without any issues. Now, can you guys guess what will be the results? So what happened? Earlier, category ID is the first field, which is of type integer. And second field is also integer, third field is character, string. Whereas here, all the three fields are string. Okay, but the delimiter is control. So this one is alphanumeric string. Because the delimiter is control A, and as there is no control A in this entire value is considered to be part of one column, and as there are no other values satisfying the other two, it just print the entire record as the first column and then null characters for the other two fields. Okay, so you will see all kind of weird issues if your table structure does not match with your data. So you have to be extremely careful. Okay, now I am dropping this table again. And I will give you a so here conversion is pretty straightforward. If it is int, use int. If it is big int, use big int. If it is float, use float. If it is timestamp, use timestamp. For char, varchar, date, etc., I will still recommend you guys to use string only. Okay. For almost all the other types, try to use string, where you will store alphanumeric characters. The conversion will be pretty straightforward. You just have to validate against this list and see which one suits for you and use that. Okay. Now I will give you a gist link, which will help you to create all the tables pretty quickly. Okay. I'm giving in chart. I'm giving it in the Hive, and also I'm giving it in a YouTube live session. Okay, and now you can copy this script. All our data is comma separated, so we are trying to create tables for all the 6 tables. So you can just copy and paste these 6 tables, create table commands, and I will cover this load command a little bit later, but run these load commands also. Okay, now you have all the 6 tables with the data loaded. I will give 5 minutes time, so make sure you go to that location, copy tables, create table command, run the create table commands, and then first you have to create the database with your OS username, and then switch to the database using use command, then create tables, then load data into those tables, and then run show tables command, which should give those 6 tables, and you can also run few queries against those 6 tables to make sure that you get all the data. Okay, and to preview the data, you can use select, for example, from order items. If you want to preview few records, never run, just select start from table name, use limit and give 10 or 100, whatever is your choice, and then you should see the data like this. Okay, I will give 5 minutes time, and now it's 4:03, so I will give up to 4:10. Make sure you create tables, load data, and run some queries against those things. And you can use this gist to to perform those things.
Then
Yeah. So when loading the data, right? So do we need to give a local path or the?
Yeah, we have to give the local path. That's if we use local in path, we have to give local path. So I will tell you load data command in detail in a moment. Is it working? Are you able to copy the data?
No, see, I'm using my local path where we have the data.
No, you are on your machine.
Right.
You have to connect to the gateway node.
I'm on gateway node and Hive.
Yeah, so okay, so this is the path on your PC.
Right.
That is nothing. That means nothing to the gateway node.
Okay.
You are on the gateway node. You have to use the local path of the gateway node. And this is the path /data/data_db. And you should use this only. Or you have to copy to your location, which is /home/ your OS username. If you have files over there, you can copy. So it's the local path of the gateway node. Okay. So people online, have you guys created the tables and loaded data? Anyway, so let's move further. Do you need more time or can we? Okay. You just copy paste this thing, it will work. So now let us understand what is this load command. So out of the create table command, we have understood the data types. We have understood about row format and especially to specify the delimiter. I will come back to file formats in a moment. By default, it's text file. We have created all the tables with default because we didn't specify which is text file. And hence we need to have whatever. So now let us understand how to load data into those tables once created. Primarily, there are two ways of loading the data. One is using load data command, and second one is using insert command. Okay, so one of the very important thing which you need to understand is the difference between the two, load command and the insert command. If you have to load data from local file system into Hive table, you have to use load command. Okay, and how the load command work? Load command works similar to Hadoop fs -put or -copy from local. You have seen the Hadoop fs command -put to copy files from the local file system into HDFS. So load command is a variation of that. Instead of using MapReduce, it will just take the source file and break down into blocks, and those blocks will be copied into the HDFS, and the path will be driven by the table name. Okay. Now let us understand a little bit about the table structure here. So I have 6 tables. We can get the list of tables by issuing show tables command. And then if you choose one table which is described formatted on that, and hit enter. And if you focus on the location, it starts with the column names and data types. Okay, and after that, the database name, owner who created the table, create time, access time, blah blah blah, and one of the important information is location. What is this location? This location is nothing but a HDFS directory, and this is the location. So first we need to understand the relevance of this, from where it gets this value. There is a parameter called Hive metastore warehouse.dir. Let me validate this. Yeah, this is the parameter Hive metastore warehouse.dir. In plain Apache Hive as well as Cloudera, this will be set to /user/hive/warehouse. When it comes to Hortonworks, it is /apps/hive/warehouse. Okay, so what is this? This is nothing but the Hive default base directory. All your Hive tables and Hive databases will be nothing but directories in this location, which means that your data will be typically stored in this location. There are exceptions where you can have data anywhere, but typically your data will be stored in this location when you load data through Hive. Okay, and then if you see the location after apps Hive warehouse, you have a directory name. So what? Let us understand what is this. Okay. So here I am running Hadoop fs -ls command /apps /hive /warehouse, and then I'm grepping on wlabs. And you see there is a, what is this? This is nothing but a directory. Okay. And you see there is a .db extension. So whenever you try to create a database, it is nothing but creating a directory in HDFS under apps Hive warehouse with .db extension. So whatever database name you give, it will use .db extension to that name, and it will create a directory. So a database is nothing but a directory under warehouse root directory, which is apps Hive warehouse. Okay, and when you create tables, if you do Hadoop fs -ls on this .db directory, you see there are 6 directories here. All of them are directories. And what is the name of this? Whatever we have given as part of the create table command. Okay, so departments, categories, products, etc. So a directory, a table is also nothing but a directory. In the its parent directory will be either apps Hive warehouse if it is default database. If it is some other database, it will be a directory under apps Hive warehouse with .db extension of your database name. Okay, so a table is nothing but a directory. A database is nothing but a directory. And then when you try to load the data into that location, you will see the files. Let me take order items. Okay, in this case, it's only 5 MB, 5.4 MB, and only one file. And that file is copied with the same name as the source location. Okay, and then you can also say Hadoop fs-tail and give this path. And you can see the data comma separated. Okay, so this is where this is how data is copied. Sorry, data will be preserved in HDFS when we load data using Hive approach. Okay, so what does that load command will do? It similar to -put, Hadoop fs -put. It will read the data from our files from the local file system, depending upon the size of the file. And a table is nothing but a HDFS directory. So, so what command I have run? Load data local in path data retail _db order items into table order items. This is the one I have given, right? That is the command I ran. How it will convert? It will convert like this: Hadoop fs -put or copy from local. Because I am using local here, it will be using -put or copy from local internally. And what put command requires, we need to give the source path, which is the local file system, and then that's fine. I'm just showing an example how it will be translated. And then what is the location for order items? It's apps Hive warehouse wlabs dd.db /order items. So internally it will run command similar to this. Okay, and the data will be copied, the file will be copied directly. And then if you remove this local, okay, then the path which you give here has to be HDFS path. So if you want to copy from HDFS location into a table, then you have the command will be like this. So there is -cp command to copy files from one HDFS location to another HDFS location, and there is a command called mv to move from one HDFS location to another HDFS location. So if you remove local from here and say load data in path and give HDFS location here, it will use move command, not copy command. So the data on the source file system will be deleted. Source HDFS location will be deleted, and a copy will be available under the HDFS location pointing to your Hive table. Okay, so that is load data from local file system and loading data from HDFS. So there are few restrictions because of this. What are those restrictions? If you want to use load command to load into Hive table, the data and the structure have to match exactly. Otherwise, you will see the issues like we have seen earlier. Yeah, null values or some weird results will start coming.
But while loading, it will not give any error.
It will not give any error while loading. Yeah, because it is using Hadoop fs-put command, which deals with the file. It will not look into the data, how the data is there and all. Okay, so load command, the restriction is the structure of the data and the structure which is defined while creating the table has to match. What is the structure? Your row field delimiters, row delimiters, file format like text file, sequence file, etc. All these things have to match. Only then you will see the correct results. And another way to load the data is using insert command, and insert command uses map reduce. So in case if you have to do any transformation, a transformation can be changing the delimiter, changing the file format, compressing the data, anything, any transformation that needs to be applied on the source data while loading into another table, we have to use insert command, and the transformations will be taken care as part of the generated MapReduce code when you give the insert command. We will see the example for insert command tomorrow. Okay. Now we need to understand one more thing, one more very important thing as part of the DDL. Tomorrow we'll see partitioning also. But before getting into partitioning and then seeing the insert command, we need to understand the difference between managed table and the external table. As of now, we have created 6 tables. All of these are, we just specified create table and table name. Okay. So if you do not specify external or temporary, these tables are considered to be managed tables. Okay. So first let us understand the difference from the syntax perspective. From the syntax perspective, when you try to create external table, let me try to create here. You have to say create external table. Okay, and then give the table name. I'm giving orders external. Okay, it has 4 fields: order ID, integer, order date, string, order customer ID, integer, order status, string. Okay, and if you want to specify field delimiter, you have to specify row format delimited fields terminated by comma. Okay, and when it comes to external table, you have to specify location to point to a specific location. If you don't specify, it will try to look into the typical location, which is a directory name under your database name. Okay, but typically we give the location for the external tables. Let me give the location as /user /dgajaraju /retail_db / orders. Okay, so I want to have a copy of orders in that location. Now the table is created. We can say select star from orders underscore external, and there is no data. I just created the table. So to start reading, first of all, I need to make sure that I have the directory like this. Okay. So dfs hyphen mkdir. I have created the directory. It is already existing. So let me ls on that location. Okay, as I have created the external table, it has created the directory also, but I haven't copied the data. That's why it is empty. Now I can say dfs hyphen put data. So I'm copying from local file system retail underscore db orders to this location. Okay, now the data is copied. Okay, 1 minute. Okay, this is not correct. Okay, now let me 1 minute. dfs hyphen ls data retail underscore db orders. Okay, this is local file system. Yeah, I have to give complete path. I can do this. Okay, I can do this actually. I can remove this one, and then say hyphen f. Small f. Now it work. Okay, so yeah, now it worked. Okay, so now if I run select query, limit 10, you can see the data. Okay, now the difference is if so syntactically that external while creating the table is the only difference. From the implementation perspective, if I drop this external table orders underscore external and hit enter. Okay, drop table, we don't need to specify external to drop the external table. We just have to say drop table orders external. Okay, still if I run dfs-ls command, in the location which it is pointing to, you will see the data. Okay. Whereas if I drop manage table, let us take the location, describe formatted orders, and then drop table orders. Okay. And then if you try to query this location, no such file or directory, because when we drop the manage table, automatically both the structure as well as data will be gone. Whereas for external table, only the structure will be gone, data will still be there. Other than that, there is no difference at all. When it comes to shared environments like this, we will run into some permission related issues. But in typical clusters, you will not see any difference, no performance difference, nothing, everything is same. You can use load command, insert command, everything else is same. Only thing is when it comes to manage table, the directory also, data also will be gone along with the structure when you drop. When it comes to external table, only structure will be gone. So with managed tables, I have more control on the data compared to external table. So what is the purpose of this? When everything else is same, why they have introduced two variations of tables? One is managed table and the other one is external table. So typical. So if you understand it, your data and structure are decoupled when it comes to Hive. Okay, and there will be some data sets which needs to be accessed by multiple modules, and each module might be developed with different technology. One might be one module, you might be pointing to the same location, and you might be writing Spark based application. Another module, someone else might be writing some Java JDBC based application, issuing Hive queries. Another module might be using pig script. The location is same, but different applications trying to access that. So if it is managed table, if Hive is work with Hive is done, and if that get dropped the table, what will happen? Other modules also will be impacted. If it is external table, it will not be. So only in those scenarios where one location has to be accessed with multiple modules using different technologies, you should consider external table. Otherwise, you can consider managed table. That's the only difference which I can think of. Other than that, as per my observation, there is not many differences. Okay. And finally, before we wrap up for today's session, let me create this orders table again. And load the data. There are few more things which we need to understand with load command, but before doing that, let us validate that we can access these tables from Spark SQL, because from the certification perspective, it is very important for you. I'm launching Spark Shell. And automatically on the cluster, it will launch in Hive context. So you should be able to access these tables automatically. So when it is launched, it will create two objects. One is SC pointing to Spark context, and the one is SQL context pointing to Hive context. Okay, now if I say SQL context and hit enter, it is of type Hive context. Okay, and then you can say SQL context.sql. You can say use the database name and then select all from departments. Let us see if it works. I think we have to run these things separately. Okay, now you can actually run. Select star from departments. If you want to get the data, you can say collect for each println. Now you can see the data. Okay, if you want to display, I think let's see, we can directly access the data. And if you want to display tab separated, or if you want to save the output as tab separated into other HDFS location, you can apply the map function here, and then you can say rec dot mk, because this is already of type collection. It's a different. It's a special type of collection because it's in square brackets. It is a kind of iterable. Okay, as it is iterable, we can use mk string and give the delimiter. Okay, and now you can see the data is tab delimited. And if you want to save this to Hive table, let us see if there is any API. Dot val s equal to and then s dot tab, and here save as table. Okay, and then let us see the syntax. Table name, departments, funds, Spark, and the table is saved. Now if you say show tables here, table is created here. You can see describe, formatted. Okay, you can see a little bit more details because it's generated by Spark. It is actually using Parquet file format, which is default, I think, with respect to Spark. And you can actually say select star from department. If you try to access these files and try to read it from there, you will see some binary characters and all those things. Okay, there are a few issues with respect to Parquet. Okay, I think we need to take care of some integration issues with respect to Hive. Okay, let me do this. Set Hive dot execution engine equal to mr. Now let me try this. Even then it is complaining with some metadata. But from Spark perspective, it will work without any issues. From Hive, I think we have to take care of few things. Okay, so this is how you can actually write data back into Hive databases from Spark. The reason why I'm covering this is if you go to CCS Spark and Hadoop Developer, and go to the curriculum. So as part of the revised curriculum, here use Metastore tables as an input source or an output sink for a Spark application. That means from the Spark application, they might ask you to write into Hive table. So for that, you should know this save as table. What is that? Yeah, that we can check whether it is match table or not, going to the metadata. It's a managed table. And if you look into the data type, the syntax, okay, so not this one. S dot save as table. And there are multiple ways to save. Okay, and the first one is just taking the table name. Second one, it is taking save mode. We need to understand what the save mode is. And then table name, I don't know what this source is. So we need to understand all these variations to understand the behavior. Okay, but most likely this should suffice. We will get into a few more details tomorrow. We will try to understand all the variations of the save as table, because from the certification perspective, it is important. And if you just say s.save and see what we have in the save, I need to understand the save also. Okay, so we will see these things tomorrow, because yeah, sometimes it will not work. You have to invalidate metadata and all those things. Save as table is the safer bet than this. Okay, so that being said, that's it for today. Tomorrow we will again start with the load command. We have seen only so when it comes to load command, right? So this is the command which we have used. If we remove local, we have to give the HDFS path. And so from this aspect, there are two variations: load data in path for HDFS, load data lock in path for local directory. And then we have seen example only with respect to into tables. On top of into tables, there is into override table also. So into override table, what it will do, it will delete the existing data and override the data. If I say into table, it will be append mode. If I run this command multiple times, same data will be copied into multiple files in the HDFS location pointing to this orders table. If you want to overwrite, you have to use overwrite. Into table can be used anytime you want to load new set of data. Okay, but if you are not sure that you are loading new set of data, if you want to overwrite, you have to use overwrite. So we'll start with that tomorrow, and then we will get into the partitioning, and then we'll see the insert command, and then we'll get into SQL. By Monday, we'll be done with Hive, and then Tuesday and Wednesday, Wednesday, and probably even Thursday, we will sit for we will talk about Spook. Okay. Yeah, window functions also will be covered. Okay. So that being said, thank you very much, and we'll catch up tomorrow. And those who are on YouTube live session, thank you very much for joining the session. And as I have been mentioning, you can practice by watching these videos and subscribing to the lab under labs.itversity.com. The plans are $14.95 for 31 days, $34.95 for 93 days, and $54.95 for 185 days. If you need any support while practicing, you can log those questions under discuss.itversity.com, and we'll try to answer your questions as quickly as possible. That being said, if you like this video, please click on the like button. If you want to provide the feedback, please use the comment section of the video. And if you want to share with your friends, just click on share and share with your friends. That being said, thank you. Bye.